Okay, so for number 10, we are drawing in now the shapes, and we're actually making the connection between what we're drawing and what we've been working on drawing as in comparison to what the shapes are in the model. We can use a simulation to figure out what the shapes are, or you can use your notes on what you've already done. So to start us off, this is telling you that you need to draw them on your own sheet of paper, then use the correct number of lone pairs and bonds in the simulation to see what the shape is. So that means that you do need to have this box checked right here, the molecule geometry. And then we're going to be using the single bonds and the double bonds and the lone pairs in order to figure out what the different shapes are. So for our first one, we have Ni3. So I'm going to pull up my periodic, or not my periodic table, my iPad real quick. Okay. So when we have Ni3, okay, we first have to figure out what our different valence electrons are. So from our periodic table, kind of what we've been working on, we have N. N is in group 15, so therefore it has 5 valence electrons. And then iodine is over here in group 17, so he has 7 valence electrons. And that's going to be important to us when we go to draw this, okay? So now that we have how many valence electrons, we have to decide which one of these two goes in the center. So we have to pick either say never, ever, ever hydrogen, always carbon, or the most unique one. So out of these, we have 1 nitrogen, but we have 3 iodines. Nitrogen is the most unique. So it's going to go in the center. We're going to go ahead and draw in its 5 valence electrons. So as you notice, we go around in our circle first, and then we follow up with 1. We're going to share it up or pair it up. Then we're going to draw our iodines, basically where all those single electrons are. So we're going to draw in each iodine. Each iodine is going to have 7 valence electrons. So we're going to have 1, 2, 3, 4, 5, 6, 7. We're going to draw in our next iodine. So notice I'm putting them where all the single electrons are right here. And we're going to put 1, 2, 3, 4, 5, 6, 7. Okay. Then we're going to put our last one over here with the other single electron. We're going to go 1, 2, 3, 4, 5, 6, 7. We're going to start bonding up the single electrons together. So that's where their bonds are going to go. So you can look at this shape and then decide which one of these shapes it is that are available to you. So you have your tetrahedral, trigonal, planar, trigonal pyramidal. Okay. Sorry, the bell went off. Bent or linear. Okay. And once you can either do that, or we can go back up to the simulation and we'll go ahead and use what we've got here. So just to tell you what you should be including onto our simulation is we should be including 3 bonds and then 1 lone pair. So just to show you what that means, and then for the rest of them, I probably won't show you it again, okay? We're going to go up to our simulation, and we have 1, 2, 3 bonds. So we're going to go 1, 2, 3. And then we have that 1 lone pair. So we're going to click 1 lone pair 1 time. We're going to rotate this so we can see what we're looking at. And then you also see your name right here. So trigonal pyramidal for that first one. Okay. Okay, to start over, we're going to go remove all. We're now on the second one, H2S. So what that one's going to look like is we are going to, again, look at our periodic table. We know that hydrogen is over here in group 1, so he has 1 valence electron. Sulfur is in group 16, so it's going to have 6 valence electrons. So once we've established that, we can go ahead and start drawing in what we've got. So hydrogen never, ever, ever goes in the center. So we're going to put sulfur in the center. We're going to draw its 6 valence electrons. So 1, 2, 3, 4, 5, 6. We're going to draw in our 2 hydrogens with 1 valence electron each. And now we're going to connect those single electrons like we've done already. So we could redraw this to be a little bit prettier, to have our hydrogens at a diagonal from the sulfur, and we have our 2 lone pairs on top. So if you're going to use the simulation, you want to click on 2 bonds. So click bond twice, a single bond twice, and then you're going to click 2 lone pairs, and you'll see what that geometry is going to be. Okay. All right. For the next one, we have CS2. So again, we're going to look at our periodic table. Carbon is in group 14, so it has 4 valence electrons. Sulfur is in group 16, so it has 6. We're going to go ahead and put carbon in the center. Carbon is very friendly, likes to pair up with everybody. So we have carbon in the center. We're going to put 4 dots around it. 1, 2, 3, 4. We know that we're going to have 2 sulfurs. So we're going to draw in our 2 sulfurs. 1, 2, 3, 4, 5, 6. Group 16. And we have the other sulfur. 1, 2, 3, 4, 5, 6. This one's going to look messy at first. Oops. Sorry, I didn't mean to have that covered. So we have our 6. And we're now going to match up all of our single electrons. So we're going to bond those guys, and we're going to bond that one, and we're going to bond that one. Okay? So I'm just going to redraw this so it's just a little bit prettier. Okay, we end up having carbon in the center. And if you notice, I drew 2 double bonds. So we saw this one in our assignment yesterday, or during the Zoom call yesterday. So anytime that you have 2 atoms that are bonded twice, that is a double bond. So we're going to be doing 2 double bonds on this when we go to the simulation. We're going to put our S's on the outside with 2 lone pairs each. We don't worry about putting any lone pairs into the simulation because they're on our outside. We only worry about what's on the central atom. So in the simulation, you're going to type in 2, or you're going to click on 2 double bonds. All right. Okay. The last one that you're going to have is going to be, let me get it written out. All right, CHBr3. Okay, so looking at our periodic table, just so we know what we're dealing with, carbon is in group 14, so he has 4. Hydrogen is in group 1, so he has 1. And Br, or bromine, has 7 because it's in group 17. So now that we know that, when we go to draw this, we have to decide who goes in the center. Carbon is an option, so we're going to put carbon in the center. So we're going to put carbon in the center, never ever hydrogen. Bromines are going to go on the outside. Okay, so we're going to draw out carbon, put our 4 dots around carbon. At each of these dots, we're going to draw in our other elements here, or other atoms. So I'm going to put hydrogen up there with my 1 dot. I'm going to connect the 2 single dots right there. Bromine has 7 valence electrons. So we're going to be doing those individually. I'm going to make sure that the single dot is facing this way so that these fit together like a puzzle. Okay, so we're going to go ahead and draw in our valence electrons like that. There we go. So 1, 2, 3, 4, 5, 6, 7. I'm going to connect my 2 single dots. They're bonded. We're going to do the same thing on the other ones on the outside. We're going to connect those dots. So what we're going to be typing into the simulation, or what we're going to be pushing in the simulation, is 4 bonds, and that's it, because there are no lone pairs on the center. Hopefully you can already see what shape this is going to be. Make sure that you do use the simulation if you need the help. If you don't need the help, then good luck, and make sure you pick the right shape for each one of these. All right, great job.